A number is anything I can owe you or give you. Now we have negative 5, it's a number. The absence of 5. If I now say number is a rotation, why not? Like what's you know what I mean? There's nothing stopping me from saying that, basically. So if I now say a number is a rotation by whatever quantity in the complex plane, then sure, I squared is negative 1.
Does I exist in like any physical form? Like could you see I in any way? Or?
This is the most seeing eye.
Okay.
Dog.
Seeing
eye dog. Yo, what if that's the Illuminati? Like they've been hiding from us that those dogs can just see the eye.
Sorry, I missed a lot of that. And now dogs see eye.
He said seeing eye dog.
Okay. Okay. Are you ready? Now it's time. Now it's time to do the proof. Okay. Everything is now ready, and we're gonna do the proof.
What are we doing?
Okay. I'm not gonna tell you because then that would ruin it. I want to just get to the end and kind of do it.
Is it the existence of God then?
Yep. Let's start with the Taylor series for e to the x. Okay.
The Terror series?
The Taylor series for e to the x. Someone tell me what this should be.
That was yesterday.
Okay, x to the n over n factorial. Do you remember this?
Yeah.
Do you remember why this is the case? It's because the nth derivative of this thing is just itself. So when you plug in, 0 every time, you just get 1. So fn of 0 is just 1, so you just get x to the n over n factorial. I can write this like this. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, 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 dot.
I thought I screwed that part up, but I did it great.
I thought
Okay,
this was amazing.
next.
Something similar. But...
Next, cos x. This one.
This is amazing.
No, it wasn't. I'm sorry.
Okay, cos x, it's negative 1 to the, to the n over 2n plus 1 factorial x to the 2, oh sorry, not 2n plus 1, I'm sorry. Just 2n factorial x to the 2n. Why, like how do I just know this off the top of my head? Cos is even, so I should only get the even powers, right? Cos is an even function. Okay, it alternates but starts at positive, right? Because cos of 0 is positive 1, right? And you get this, you get this factorial thing on the bottom, okay? Good. So this is equal to 1 minus x squared over 2 plus x to the 4th over 4 minus x 6 factorial, my bad, 4 factorial plus dot dot dot. Okay? Are you with me here?
Yeah.
Yeah, we're not doing anything too fancy. And then I can just write this as well. Sine x is equal to negative 1, still negative 1 to the n, because you want the first term to be like x, okay? Over 2n plus 1 factorial, x to the 2n plus 1, and I will write this is equal to x minus x cubed over 3 plus x to the 5 over 5 minus x to the 7 over 7. Are you with me?
Yeah.
I'm not doing anything fancy here. Okay. Before I continue, I would like to say that Taylor series give us something very, very special. Okay? What do we mean by, so let me just take a pause for a second. When we say 2 to the x, okay, what does this mean? When you say 2 to the 3, this is not a hard thing to define. You say 2 times 2 times 2. Okay? Or if I say e to the 4, I say e times e times e times e. E is just some number, 2.7 times itself 4 times. Okay, but of course, if you continue this pattern, e to the 4 divided by e is e to the 3, e to the 3 divided by e is e squared divided by e is e to the 1 is e divided by e should be e to the 0 is 1, right? If you just continue that pattern. E to the 0 divided by e should be e to the minus 1, so e to the minus 1 should be 1 over e, and you get this kind of nice pattern. I could do 2, I just picked e because we're talking about e to the x here. Okay, so e to the whatever is just either itself this many times, so e to the minus 2 is 1 over e to the 2, which is 1 over e to the e. So there's a very nice pattern here, okay? The number of times you multiply it, the number of e's you see is equal to the thing, and whether it's 1 over or, okay. But what if I said e to the square root 2? Okay? The thing is, if you plug this into your calculator, it will give you an answer. Okay, you've probably tried this before. This is allowed. How can I possibly make sense of this, right? Well, the way we make sense of it is by plugging it into the Taylor series. So while e to the square root 2 doesn't necessarily mean anything, how many square root, I take square root 2 e's multiplied by itself, that doesn't really mean anything. However, if we claim, and we've seen that this thing and this thing are completely equal to each other, for any x, the radius of convergence is infinity for all three of these, then I can plug root 2 into here, there's no problem there. Root 2 squared, root 2 cubed, those are not problematic. And so what the Taylor series gives us is analytic continuity. That is to say, I can now plug any real number in here. Does that make sense? Okay, so I can say e to the pi if I wanted to. What does that mean? Okay, I just take 1. This is weird. E to the pi, it's a transcendental number to the power of a transcendental number. Don't even, right? But what is this? 1 plus pi squared over 2 plus pi cubed over 6. This is not anything interesting on the right-hand side. Your calculator does this. This is what your calculator does when you plug in e to the pi. It knows how to multiply, it knows how to exponentiate, and it knows how to divide. So it can do this, okay? So that's what e to the pi is, yes. Do you have a question? I know, I see, I'm looking at your face, I can see what you look like.
Why is e to the pi like not a thing?
It is a thing.
Just like without Taylor series, why can?
Because what would it be? So like e times
You
e
get the point.
is like e times e times e 3 times like e times e times e times 0.1415 e's. Like how many e's is this?
Okay.
Like
Yeah.
there's no.
Oh, I totally get it now.
Right, there's no right. That would be pi. It wouldn't make sense. Okay, so Taylor series is really nice because it allows us to plug anything into here. Okay, anything into there. Okay.
No way. Don't do it. Don't do it, man.
Don't do it, son. I'm gonna do it. I'm gonna do it. Look at this. Look at this. Here's where the Illuminati shows up. Look at this. This is not random. 1, x squared, x cubed, x to the 4, x to the 5. The sine has all the odd ones. The cos has all the even ones. Okay? The e has all of them.
Whoa.
This is filling, these two together will be almost exactly like this.
Oh no.
Okay? So what I'm gonna do is I'm gonna add cos x plus sine x. Are you with me?
Oh wow.
Cos x plus sine x. Cos x plus sine x is, I just add these two things together. 1 plus x minus x squared over 2 factorial minus x cubed over 3 factorial.
Plus x4 over 4 factorial.
Thank you. Plus x to the 4 over 4 factorial.
Plus x5 to the 5.
Plus x to the 5 over 5 factorial minus x to the 6 over 6 factorial minus x to the 7 over 7 factorial plus dot 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 dot. Look at this pattern. Positive, positive, negative, negative, positive, positive, negative, negative. Positive, positive, negative, negative, positive, positive, negative, negative.
Okay.
Every other term here is positive, positive, negative, negative. And each odd term, so if I call this the 0th term, the first term, okay? So I say this is 0th, first. I'm getting nervous. You're getting nervous. I'm getting nervous. Okay. This is the second. This is the third. The odd ones all have an I. Okay? The even ones all have a 1.
Yeah.
So what does that mean? If I go over here and I, instead of cos x plus sine x, I multiply all the odd terms, so I stick an I in here, okay? I in there, I in here, I in there, I in here. Okay? Well, okay, that's gonna give me, okay, so watch what happens here. Can you see? Can you see this? Okay.
I can't see it.
So what I'm going to do is multiply all the odd terms by an I. So I'm going to get that pattern, right? So I'm going to get, what am I going to get? I'm going to get 1 plus ix. Yeah? Okay, I'm going to get minus, so okay, how many steps should I do this in? I'm going to do it just straight up, okay? So I'm going to get, so this is now x squared plus ix squared over 2 factorial. Why is that? Okay, because I squared is negative 1. Okay, and now this term needs an I in front of it, so I'm going to get plus ix cubed over 3 factorial. Is that okay? Because I cubed is negative 1. Oh, sorry, I cubed is negative I, and I want the I in front of the sign terms. Okay, I want an I in front of every sign. Let me just add the I right here. 1 plus ix plus minus I plus I. Okay, I want the i's to appear on those odd terms. So I cubed, we've seen, I cubed is negative I. That's what we want. Okay, plus. Okay, that's the cube. The fourth is going to give me, I want even, so I get ix to the 4 over 4 factorial. Is that okay? Because I to the 4 is, I go around 4 times 1, 2, 3, 4, back to 1. Okay, plus ix to the 5 over 5 factorial. Are you with me?
Yeah.
Okay, so what does this say? Cos x plus I sine x is equal to, I can write this in a beautiful summation notation, the sum from n equals 0 to infinity of what? Ix to the n over n factorial, and I look over here. What is this? Okay? This is e to the ix.
Whoa.
Okay? So we get this, cos x plus I sine x is equal to e to the I. So I'm going to write that in a box. Cos x plus I sine x.
Can we ask questions about this?
But let me just finish this, because we're not done. This in and of itself is weird and remarkable. Okay? And I will give you another more intuitive explanation for why this is true. But first you have to see why it's true in the Taylor series. And I'm going to give you an explanation on the complex plane why this is true too. Right? So I'll give you a graphical explanation. However, let me first do something. If these things are truly... So first of all, the Taylor series are true. There's no denying that. The Taylor series are equal to each other. Okay? I stick the i's in front of these signs and the cos there, and then an I in front of here. I get the pattern. It's true. That's just a matter of matching things to equal each other. But if it's true that these things are true, then I can plug in any x. The radius of convergence on these things is infinity. I can plug in any value for x, including x equals pi.
Don't do it.
I gotta do it, Donovan. I'm sorry, I gotta do it, man. I gotta do it. I gotta do it, man. What is cos of pi? Cos of pi. Cos of pi is -1, right? Cos of 0 is 0, 1. Cos of 90 is 0. Cos of pi is -1. So here I get -1 plus what is sine of pi? 0. E to the I pi is equal to -1. E to the I pi plus 1 is equal to 0. Here we go. You ready? Let's go through them. 0. Boom. E. Boom. Pi.
Oh,
I. 5 most important numbers are all related by one equation.
No way. It's like the theory of everything.
well, there's
Illuminati.
Theory of everything. Can you write that below it?
no, but there's an actual theory.
What are you doing? What are those?
Those are
Oh,
Illuminati.
kind of looks like Cool with a triangle.
They're on to us, man. They're on to us.
But this is all like based on human construction. Like I wouldn't say that's a proof of God.
Well, no, some people have looked at this and go, this is too good to be true. So the reason that people
Oh, it's like a
use this to
Descartes
explain
thing.
the existence
Okay.
of God is that this cannot, these numbers have, this has nothing, this makes no sense. E, where did E come from?
Yeah.
E came from continuously compounding interest. That's where it comes from. People giving money to each other, they discovered this number. Pi, where's pi come from? Pi just came from people drew circles in the sand and found there's this thing that's common to every circle. I was helpful because
This is too much.
I was helpful because when solving equations, people found that sometimes you would solve, x is equal to the cube root of 3, you would get like the cube root of -1, the cube root square root of -1. What does that mean? They had to introduce I. 1 is need no introduction. 0 is 0.
No, but I don't get how e to the I pi plus 1 equals 0.
Okay, well, e to the I pi on this side is equal to -1 plus 0. So if I bring this -1 over, right, if this is true, if you accept this is true from the Taylor series, you have no choice but to accept that this is true
It's a
from the Taylor
deductive
series.
argument.
Well, all of math is a deductive
Yeah,
argument.
but
Okay. This is an especially deductive argument. This is -1 plus...
Like Dr. Galai would be
This
so
is
proud of me.
-1 plus 0 is equal to e to the I pi. So move this -1 over. E to the I pi plus 1 is equal to 0.
This is amazing.
Do you think God exists then?
No.
But it
You don't?
Me? No.
But what about that?
That's not necessarily proof of God.
No, I mean...
No, I'm just asking you that. Like, we just lucked out. Like, that just happened.
But like it's not like
This to me, okay, I don't want to get into like a
Let's talk about it.
political
We got a
no,
minute.
no, I don't want to. No, that's not good. But this is the closest to a good proof I've ever seen for the existence of God. Okay.
But it's like,